Hey, so I'm going to be making a video on transformations using Desmos. So what I recommend for your presentations is that you do something very similar. You see all of these are turned off. I'm gonna turn on one of them. So I'm gonna turn on this one. So now there's a couple of things I know about this. First, I know it's a quadratic because of the way it looks. I could tell from the shape here, and I could also tell because there's a 2 up here. This function has a 2. So now let's start with A. This is one of the hardest ones. So if I make A a big number, what happens is that it shrinks. Well, what actually happens is that it increases much faster, making it look like it's shrinking, but really what's happening is that it's going up so fast that it looks like it's getting like skinnier. Now, if I make a 0, it just becomes a line. If I make a negative number, it's the same as if it were just 10, but the negative flips it. We call that a reflection. It's a reflection of the at the special point here. So now h, this is a tricky one. H goes inside. You see how it's inside? Like before I square it, I'm gonna subtract h. So when I move h to the right, okay, make it bigger, it's gonna move to the right. If I make h smaller, it's going to move to the left, right? So this is super important to know is that h, it's always going to be inside. You see how it's inside, inside? It's always inside the function before you do it. So like this happens before you apply the function, the main part of the function, which is either the square, the cubic, the absolute, or the square root, for example. Um, and then we have 8k, which that one's a little bit easier because if you just make it big, it goes up. If you make it small, it goes down, right? So it's super important that we notice that k is always at the end, like in the outside. It's like not inside of the function. It's outside. And then a is always like kind of next to the function. Um, so Um, Once again, A helps us make it either flips it or it makes it wider or narrower. H makes it go left, right, and K makes it go up and down. So um, A is what we call A is used to represent dilation and reflection. Um, let's see, H is used to represent a horizontal shift of the graph, and then K is um, K is used to represent a vertical shift of the graph. Okay, so you can pause the video and copy these notes and put it inside your paper. That's fine. I would encourage that. In fact, I might even encourage you to use this again in your presentation. Um, so all of this applies to not just the quadratic, so I'm going to turn off the quadratic. Let's do something like the square root. So if I change a to negative, what do you think is going to happen? Okay, if you say that it's going to flip upside down, you're right. See? So when it's negative, it flips. If it's positive, it goes in that direction. When I make a really big number, it's gonna just, again, it's not that it's gonna make it wider or narrow. Just think of it as it's making it increase faster. So it's gonna go up faster or it's gonna go down faster if you make it smaller. Um, see? And then H, again, it lets us move it left or right, left or right. And K is up and down, right? So we call this dilation reflection on A. H is used to represent a horizontal. So horizontal means like from left to right. Um, and K is used to represent a vertical shift of the graph. So that's k here. So these are the transformations that we use. Now, if you want to get a little bit more advanced, you can talk about the special point. Every one of these graphs has a special point that helps us track it. So for example, let's do a very difficult one in the cubic. So the cubic has a special point here. It's the point where the graph like changes direction. So you see how it's like going down and then it hits like this flat place and then it starts going down again. It's like where it starts to curve. So notice that if I move h, the special point matches h. So look, you see how h is 6 here? If you look at with the x coordinate of h, bam, it's right on 6. If I make, let's make k 3. If I make k 3, notice that the, let's make it 4. Notice that the y value is going to be 4. So h and k are actually always going to be the x and y values for the special point. Now this is something that we did learn in class, but if you feel like it's something you don't really understand, it's fine. You can you can try to mention it if you want, or you can ask me more questions about it. But basically this is true for all these functions, so I'm going to turn all of them on. It's kind of, let's turn on 2. See, they both have the special point in the same place. If I change k and h, the numbers that are here are going to match the numbers that are in the graph. Yeah, so I hope this was useful. If you want, I can make a little bit more videos. Um, just let me know, okay? Uh, I'll see you later.